Okay, so hello and welcome, and we're looking at grade 11 and 12 final examination revision. In today's session, we are looking specifically at analytical geometry. This is presented by the Youth Academy for Leadership Excellence, so be sure to check out our Facebook page by typing in ELS 2014 as one word, or just Youth Academy for Leadership Excellence. Okay, so let's get straight into it. Now, as a quick crash course, the three most familiar, well-known formulae that you also find on your data sheets for the grade 12 examination is the distance formula, which basically gives you the distance between any 2 points on a Cartesian plane, right, expressed in terms of an x and a y. Then we have the midpoint formula that gives you the midpoint of a line, as well as the gradient formula, which gives you an idea of the object's slope. Okay, so what I'm going to try and do in this video is go through the questions and then tackle the questions, or tackle the formulae and explanations of the formulae when the distance or midpoint or gradient arises. Right. Okay, so here's the first question that we've got over here, and the question reads: M is the midpoint of the straight line joining A, which has got coordinates 3 and 2, as well as B, which has got coordinates 5 and 10. So those are two important things that we will choose to more or less underline over there. I'm just going to change its shape. Let's just make it a straight line. Right, so there we've got B, which is 5 and 10, and we've got A, which is 3 and 2. Okay, find the equation of the line that goes through M that is perpendicular to AB. Okay, so this is a little bit of a complex question because, like I said, it is revision. So we've got a few things to look at here. We've got a line, and then we've got the line passes through the point M, but M happens to be the midpoint of A and B. So let's deal with that first. I've got A and I've got B, and I want to find the midpoint. So the midpoint formula basically says it's going to be x1 plus x2 over 2, and then the y coordinate is going to be y1 plus y2 over 2, and that will give you the midpoint, right? So this here would be considered our x1 and y1 and x2 and y2. Okay, we don't mix them up. We have an x and a y, and then we say this is group number 2, and we've got an x and a y over here, and we say that's group number 1. Okay, so what can I do with this? I can say, well, x1 is going to be 3 and x2 is going to be 5, so I'm going to say 3 plus 5 divided by 2, and the other one is going to be 2 plus 10 divided by 2. Okay, and then that over there is going to give us the coordinates of M. Right, so what is 3 plus 5? 3 plus 5 is 8. 8 divided by 2. Oops, that's my bad. Let's just get that back over there. Okay, so we back over there. 3 plus 5 is 8. 8 divided by 2, what does that give us? That's going to give us 4. And then over here, 2 plus 10 is 12. 12 divided by 2 is 6. So this gives us the coordinates of M, right? So I'm going to just put there big M. M has got coordinates 4 and 6. So now we know that, right? Find the equation of the line that goes through M but is perpendicular to AB. So if I had to draw this, I could say, for example, this is A, and I could say that, let's just get a shape there. I could say I'm drawing that. That would be B, point B over there. And somewhere in the middle I've got M, which is over there. And that M in itself actually has a line that goes through it that is perpendicular, right? So if the line is perpendicular, the line looks something like this. It passes through M and it's perpendicular to AB, right? Now, that's what perpendicular means. It means it meets at a right angle at 90 degrees. So there's something about gradients. Now in the previous slides I went over what the gradient looks like, and there's a formula for the gradient. So the gradient formula is the following. It's M is equal to change in y over change in x, or y2 minus y1 over x2 minus x1. And we've already seen what we've made. That's x2 y2, and we've made this one x1 y1. Right. Okay, so y2 minus y1 over x2 minus x1. Now if I specifically want this for A and B, I can say, well, MAB is going to be right, it's going to be yb minus ya, which is basically the y2 and y1 respectively, over xb minus xa. And let's type that in. Let's see what we get. If I had to put it in, I'm going to say it's 10 minus 2 over 5 minus 3. And what is 10 minus 2? That's 8. And 5 minus 3 is 2. And then that says my gradient's going to be 4. Just double check that answer and convince yourself it's true. Okay, so with the next part over here, if I want to consider, I know the gradient of this line. The gradient of this line is 4. There's a property that relates to perpendicular gradients. And so I'm just going to start up a new sheet and tell you about perpendicular gradients. And you might as well take a note. Perpendicular gradients, right? What do we know about lines that have perpendicular gradients? Well, firstly, we know what's perpendicular. Perpendicular means that a line meets at a right angle. So if I take a line, I draw a line down like that, and I draw another line there, and I consider this line AB. So there's point A, there's B, and then I've got C and I've got D there. If they meet at a right angle indicated by such a block, I say the following. I say that line AB is going to be perpendicular to line CD as such. Okay, now something about the gradients is very important. There's a property. It says that the gradient of AB, when I multiply it with the gradient of CD, I get an answer of -1. If this is true, then the line AB is perpendicular to the line CD. Okay, the line AB is perpendicular to the line CD if I take the gradients and I multiply them and they give me -1. Okay, so going back to our previous slide, I know the gradient of this line is going to be 4. I know that this line is perpendicular. So if I say MAB, right, and I multiply it by, let's give this line CD for argument's sake, by MCD, it must equal -1. So here's the big question. What will the gradient of this be? If this gradient is 4, what must I multiply it by to get -1 as an answer? I need to multiply it by a negative number, and that negative number should be the reciprocal of 4, which is 1 over 4. And you can multiply that out and you'll see you'll get -1. Okay, so we've learned two things so far. We've already applied the midpoint formula, even though it's just in one question. We've also applied the gradient formula, and we've also applied the principle where we can find that two lines are perpendicular and the other gradient will be the negative reciprocal of the first gradient. Okay, the negative reciprocal of the first gradient. It means if the gradient is 3 over 2, you flip it and you get 2 over 3 and you make it negative if the lines are perpendicular. And this is the relationship between the gradients. Okay, so let me bring up another new sheet quickly and let's take some of those things back. We said M has got coordinates 4 and 6, right? And that's the midpoint of A and B. Okay, so let's just list that there. That's going to be the midpoint of A and B. That is the coordinates M. And then we've also got the gradient of the line that goes through AB. The gradient of the line AB is equal to 4. But now we are not interested in the gradient of that line, but rather the line that goes through M but is perpendicular to AB, and that's the more important one here. So we've got that midpoint. We're going to say the M of the line that's perpendicular to AB, that is equal to -1 over 4. Now the last thing left for us to do here is to actually just find the equation of that line. So how do I find the equation of that line? So I say y is equal to mx plus c. Y is equal to mx plus c. That is the general formula for a straight line. And in order to get this, we say that y is a function of x. In other words, I throw in an x, I get out a y. So if I want the general formula, at the end of the day, what I need to have is only x and y unknown, right? Only my x and only my y must be unknown, which means I need to throw in an m, and that's part of the equation, and I need to find the value of c. So let's see how we do that. Okay, we need to have the gradient. So we know the gradient of this line is going to be equal to -1/4 x plus c, right? And now I need to solve for the value of c. How am I going to do that? Well, I'm going to say let's take a point that's on that line. That means I'm going to put in an x and a y. Now a is not on that line, neither is b, right? So if I go back, you can see here a is 3 and 2 and b is 5 and 10. I know the diagram doesn't make complete sense, but I said for argument's sake, if it looked like that, I'm sure that this would be slightly rotated. But if I know this gradient is 4, I know this gradient is minus 1 over 4, and I also know that a and b don't fall on this line, but m does. So the coordinates of m was 4 and 6. 4 is the x, 6 is the y. So let's do that. Let's make it 6 is equal to minus 1 over 4 multiplied by 4 plus c. That's going to give me 6 equals minus 1 because the 4's cancel with one another, and therefore I get a value of c is equal to 7. And that gives me the equation of my straight line, right? So my final straight line is y is equal to minus 1 over 4x plus 7. And there we go. So in this question, you've actually addressed three things. You've dealt with the midpoint formula, right? You've dealt with perpendicular gradients, and you can list this to say these are skills you now know and need to practice. Midpoint formula, perpendicular gradients, as well as the equation of a straight line. And there we go. Three things for this video.